Hello, my name is Calhoun, and I will be presenting a project I worked on named Two-Factor Authentication System using face patterns and thumb joystick. For this project, I was mentored by Sup Jen Lee. I will start off with introducing the project. Next, I will describe some related works to the project. After that, I will discuss the overview of the entire project. Then, I will get into the main parts of the project, such as the Raspberry Pi, Arduino Uno with thumb joystick, serial communication with USB, the camera, and the database. Lastly, I will explain the authorization process, show and explain the verifications, in detail the conclusion, and some future works that can be worked on. Authentication. Two-factor authentication is using a two-way combination of what you have, what you know, or what you are as a means of extra security for authentication. The scope of this project is that it would be a two-factor authentication system that will run on a Raspberry Pi and use OpenCV as a means of recognizing the user face. A joystick will be needed to get patterns from the user, and an Arduino Uno to get the joystick values and provide serial communication between the joystick and the Raspberry Pi. The system has a database to hold user pattern codes and images. Lastly, the user will be authenticated if the user face and pattern code entered into the system matches the face and the corresponding pattern code in the database. The project objectives was to first set up the Raspberry Pi, next install OpenCV, then set up the joystick, the Arduino Uno, and next install and set up the database on the Raspberry Pi. And lastly, I created the Python main code to bring all objectives together and make them work on the Raspberry Pi. I worked on this project to improve my programming and problem-solving skills while also learning how to set up hardware for the Raspberry Pi, Arduino Uno, and joystick. The motivation behind this project was to find a cheaper, accurate, and more secure way of getting authentication from users. Project is the Apple two-factor system and the Amazon two-factor system. The Apple two-factor system is an extra layer of security for an Apple ID so that a user is the only one who can access their account. The system rests by having the user enter their password, and if correct, a verification code is sent to the user phone number. The Amazon two-factor system is a two-step security feature that helps a user protect their Amazon account by adding an extra layer of security to their account login. The system works by having the user first enter their account email, next they will enter their password, then their phone number will be sent a login code by text message, voice call, or through an authentication app to generate a code that the user can use for verification. It works because your phone number is linked to the phone SIM card, so unless an attacker can get your phone, even if they have your password, they still cannot access your account. What makes this project unique from the others is that the others use what you have and what you know for authentication. This project uses what you know as in the joystick passcode and what you are as in the webcam getting the user face for biometric authentication. As we can see on the Apple two-factor figures, first the user must enter their Apple ID email and password. Then a verification code is sent to the phone number by text message. On the phone number device, the verification code is shown. They enter the code on the device that is being signed in. After that, enter the device passcode of the device the phone number was sent to. Now you will be verified, and iCloud remembers the device so you won't have to go through the process all over again. With the Amazon two-factor system, you first start out with entering your email for the Amazon account. Next, you will be prompted to enter the password for the Amazon account. Then a verification code is sent to the phone number device by text message. After you have gotten the code, enter into the two-step verification prompt on the Amazon website or app. Then you will be verified. The overview of the project is the Raspberry Pi connects a camera and a database is installed and set up on the Raspberry Pi. For the camera, OpenCV is installed to recognize faces from the webcam. The Arduino is connected to the thumb joystick by pins on the Arduino. A C program is written to get the thumb joystick values. The Arduino has a Type B cable port which connects the USB Type B cable to the Raspberry Pi for serial communication between the Raspberry Pi and the thumb joystick. Back on the Raspberry Pi, the main code is written using the Python programming language to get face recognition from the user using OpenCV, get data from the thumb joystick, and to get information from the database. The Raspberry Pi is the main device in which the system will run on. The webcam is connected to the Raspberry Pi to get the user face. The Arduino and joystick is connected through the USB Type B cable, and it is where the main Python program will run. The Arduino is used to connect the joystick and get values from the joystick. It also communicates with the Raspberry Pi through the Type B cable. Connect the USB Type B cable to the Arduino and then connect the Type A side to the Raspberry Pi. In the main Python program on the Raspberry Pi, a code is written to get values from the Arduino. In this section, the Raspberry Pi is discussed. The Raspberry Pi is a small computing device that is cheaper than most other forms of computers, and it is good for computing projects. The Raspberry Pi is a mini motherboard, and it is optional to purchase a case for it. For this project, the Raspberry Pi was put into a case with a heatsink and a cooling fan. The micro SD card was shipped with the Raspberry Pi loaded with noobs, and the operating system chosen was the Raspbian operating system. Also shipped with the Raspberry Pi is a micro SD card reader, 2 micro HDMI cables, and a 3A USB-C power adapter. To set up the Raspberry Pi, if the Raspberry Pi was ordered with the case, the first thing to do is to put the Raspberry Pi in the case. If heatsinks came with the case, put the larger heatsink on the Broadcom CPU, the rectangular heatsink on the SD-RAM chip, and a smaller square heatsink on the USB 3.0 controller. If a cooling fan came with the Raspberry Pi, insert the red cable into pin 4 or pin 1 if you want the cooling fan to run quieter, and put the black cable into pin 6. Next, close the case and then insert the micro SD card to the SD card slot at the bottom of the Raspberry Pi if the card has noobs already installed. What noobs is a straightforward way to install an operating system. If noobs is not on the SD card, you can download Raspberry Pi Imager from raspberrypi.org downloads to a Windows PC, install it, and you can install the Raspbian operating system from the Raspberry Pi Imager. If you want to install noobs onto an SD card, you can download it from raspberrypi.org, downloads noobs, and unzip the file and place the contents into the micro SD card. Make sure that micro SD card is FAT32 formatted. After the micro SD card is set up, add a keyboard and mouse to the Raspberry Pi. Connect the micro HDMI cable to a monitor or a TV. Connect the power cable to the Raspberry Pi, and connect the Pi to the network by Ethernet or Wi-Fi. Select the operating system if noobs is used. If Imager is used, the chosen operating system is already installed. Follow the on-screen instructions to set up the system. Next up is the Arduino Uno. The Arduino Uno is a microcontroller board device that have input-output pins. For this project, the Arduino Uno is controlling a 2-axis thumb joystick. The joystick is connected to a breakout board and is soldered to the board. A 5-pin header is connected to the front of the breakout board and is soldered to the board. Then 5 male to female jumper cables are connected to the 5-pin header. Note that I soldered header into the breakout board, but you can buy a joystick with headers already connected to the breakout board. To set up the joystick and connect it to the Arduino, first you need to connect the joystick base to the breakout board, then solder the base or the bottom part of the breakout board where the pins are sticking out. Put the 5-pin header to the 5 slots in front of the breakout board and solder the headers into the breakout board from the bottom where you previously soldered. Note to make sure that the solders are not connected to other soldered parts. Insert 5 female ends from the male to female jumper cable into each of the 5-pin header. On the analog side of the Arduino, for the 5V slot, insert the VCC male jumper cable. For the A0 slot, insert the X out male jumper cable. For the A1 slot, insert the Y out male jumper cable. And for any ground slot, insert the ground male jumper cable. On the digital side of the Arduino, for the 2 slot, insert the select male jumper cable. This is the Arduino IDE code to the thumb joystick data. The code detects the pins that are connected to the Arduino to get the values from the joystick, then the serial communication begins. If the user moves the X pin on the joystick forward, the value will be 1023 and the program will display the word up. If the user moves the X pin on the joystick backwards, the value will be 0 and the program will display the word down. If the user moves the Y pin on the joystick right, the value will be 1023 and the program will display the word right. If the user moves the Y pin on the joystick left, the value will be 0 and the program will display the word left. If the user presses the joystick button down, the value will be 0 and the program will display the word select. At the 4 values have been entered, the user can re-enter values. Now we will discuss serial communication. The Type B USB cable is for serial communication between the Arduino Uno and the Raspberry Pi. To get values from the joystick, the Arduino Uno needs to be uploaded with a C programming code to get values. This is done in the Arduino IDE. The Arduino IDE is a software that is used to write C or C++ code uploaded to the Arduino Uno. You can install Arduino IDE from the arduino.cc in main software. Download the software, install it, run it, and first plug in the Type B cable to the Arduino, then put the other end into a Type A USB slot on the computer running Windows. On the program, open Arduino IDE, go to Board on the Tools menu, and select Arduino Uno. Then go to Serial Port and make sure the Arduino Uno device is selected. type the code, and after finishing, press verify, then upload. This is the Python code to get values from the Arduino to the Raspberry Pi. First, serial communication is started from the Arduino by importing the serial library and stating the device name in the serial statement. Serial communication is started when a user moves the joystick. The program will get 4 values, and the values are added to a list. Then the 4 values are displayed. Serial communication does not stop until the program is ended, meaning the user can re-enter 4 values. For this project, a high-definition or 1080 pixel webcam is used. This is so that it will be clearer when capturing the user face. To recognize the faces, OpenCV needs to be installed in the Python programming language. This will be done through the command line in the Raspberry Pi. To install OpenCV, first you must update, then upgrade the system, which is steps 1 and 2. Now install the packages. First install the package needed to compile OpenCV, which is CMake. Then install the image and video format packages. Next install the OpenCV interface packages. Install the G4Trend package. Install the HDL5 packages. Then install the Python 3 dev, Python 3 pip, and Python 3 numpy packages. These are steps 3 through 9. After installing the packages, open the swap file and find configure swap size equal 100. Replace 100 with 2048, then restart the swap file. These are steps 10 through 12. Then clone the 2 OpenCV repositories, steps 13 and 14. And next, create a directory called build, then change directories to the build directory. Then run the CMake package. Next, compile OpenCV by running the make command. Then install OpenCV, running make install. Then run ldconfig to find OpenCV. These are steps 15 through 20. After installing OpenCV, open the swap file and find config swap size equal 2048 and change it back to 100. Lastly, restart the swap file, steps 21 through 23. Note, press Ctrl and X followed by Y, then enter to save the swap file. This is the Python code to run OpenCV. The program takes in image files and put those files into a list. The images is then encoded, which creates an array for each image. Then the array is added to a list. In the main function of the code, the video feed is captured and each frame is checked to see if the image frames matches the image encoded in the find encoding function. The images from the find encodings function is matched with the video frame encodings to see if they are the same. If the matches are the same, the name of the person is displayed on the screen via a green rectangle box, and the video is displayed from the webcam as well. After a person enters queue, the program is terminated. The database used for this system is MariaDB. To install MariaDB, update and upgrade the Raspberry Pi from the command line. Note that you can skip this if you recently updated and upgraded the device. Next, in the command line, install MariaDB server, then security install. When prompt, press enter, press Y to set new password, press Y 3 times, then press Y again to reload privileges. To start MariaDB, in the command line, run mysql-u root-p. Next, create the database and give the database a name. Next, type use, then the database name. Now you can create a table, and after creating the table, insert some values into the table. For this, I created table IoT with column person image and pattern code. I inserted images into person image and the code patterns to pattern code. This code connects to the MariaDB database, retrieves the information from the database, and the table column that is listed in the execute statement. The values from the column in the table are added to a list, and afterwards, the connection is closed. This section explains the authorization process. For authorization, first the user face is detected or face recognized by the program from the webcam. If the detected face matches a face in the database, then the program prompts the user to enter their passcode. If the pattern the user enters matches the corresponding pattern of the matched face in the database, then the user will be authorized. If the user face does not match any faces in the database, then the user will not be authorized. Also, if the user face matches a face in the database, then when the user is prompted to enter their pattern, if the pattern does not match the corresponding pattern of the matched face in the database, the user will not be authorized. This is the authorization process code. The description of the code is that the images that are in the system are added and encoded in the find encoding function, and the values are added to a list. The get joystick function gets the joystick values through serial communication from the Arduino. The get joy database connects to the database and retrieves the joystick pattern from the database. The get image database connects to the database and retrieves the images of all users from the database. In the main function, the get image database and get joy database functions are called. The get image database images are put into a list and passed as an argument of value to the find encoding function call so that the database images can be encoded. It also gets the file root name. Next, the webcam starts video capture and is displayed on the screen, and the program gets the face location of the user. The frames of the video feed are encoded for faces and returns the frame with the recognized face. The frame with the user face is compared with the encoded images from the database to check if there is a match. If there is a match, the face distance of the matched face and unmatched face are guided. Also, the video feed display will show the name of the matched user. The matched image is gotten from the encoded database images, and then the get joystick function is called to get the user joystick values. The user joystick values are compared with the database pattern code from the corresponding matched database image. If the webcam recognizes user frame and encoded database image match, and if the corresponding matched database image and the user entered joystick pattern match, the user will be authenticated. Otherwise, if neither the image nor the pattern does not match, the user will not be authenticated. When a security personnel presses Q, the program will terminate and stop video capture from the webcam. For confirmation purposes, the images that are in the system are added and encoded in the find encoding function, and the values are added to a list. In the main program, the video frames are checked to see if they match the find encoding function images. If the images match, the webcam pauses the video frame and then asks for the user to enter their passcode. If it matches the passcode in the database, the user is confirmed. As you can see from the database slide image and the pattern entered into the program, me and Elon are verified. If the user image is not in the system, the program will just give an unconfirmed prompt for each video frame that is of no match. From the database slide image, Bill Gates' photo is not in it, so it does not have a prompt to enter a pattern code. In conclusion, the two-factor authentication on the Raspberry Pi works well. This can be implemented for increased security in different parts of the school. This is also cheap so that it can be used over other security methods. The Python program can be improved upon by adding a feature to send an email to a person who oversees security for access. A Python code can be made for quicker inserting of information into the database. The responsiveness of the joystick can be improved. Also, continue to try to get the program to run from images being ran from a different directory than the program. These are the references I used in the presentation. These are the files I created over the duration of the project, screenshotted, then put into the presentation. That is the end of this presentation. Thank you for listening and watching my presentation.